Hey guys, it's Nick from EGuru.com. Today we're going to be talking about voltage. Not a whole lot of reference sheet stuff today, it's just a lot of a qualitative analysis. One thing you're going to want to know is the units for volt. We normally define it as a V. 1 volt is 1 joule per 1 coulomb. So we're going to see how much energy per charge there is. So what is voltage? So we're going to go back to our handy dandy stool and water analogy. Voltage you could think of as a pressure. So if we poked a hole in this again and water spilled out, you could think of it as how much pressure is in the water right here. So if you stuck your hand in here, how hard is it going to hit you? That's kind of. So another way to think about this is potential. Oftentimes people will say potential instead of voltage. They'll just say the electrical potential. So if you ever hear somebody say the electrical potential, they're talking about voltage. So what is the potential energy of the water, any water molecule right here? Well, you probably know from your physics class, you just pick the weight of the molecule times the height. So it's kind of the same thing. What is the energy potential of it that it has to hit your hand? Really the way that I like to think about it and the way that most people like to think about it is just pressure. Voltage is analogous to pressure in a water system. So let's look at this another way. This guy right here is a water pump. I didn't really know how to draw a water pump, so I just drew that. And let's hook up some water pipes to this. And the water is going to flow out this way and up. And then we're going to draw the other side. These two pipes are not connected. So if we're currently pumping water out as much as we can, this is going to fill up with pressure, right? So let's say we have something like 5 psi on this side. And on this side, on the other side, there's just water getting sucked in. We don't have any water in there to feed into this pump right here. So we're going to be at 0 psi on this side. So you could say that the potential difference between these two is 5 psi. The voltage, the water voltage, I guess we're saying that. So let's do an electrical example. So let's say we have this battery here. This is a symbol for battery. And on this battery is charged up to 5 volts. Now we have our wires the same way we have our tubes in the water example, and there's a switch right here. And this switch is open. So no electricity is flowing through. There's no there's no current. No current. So on this side of the switch, you're going to have 5 volts. And that 5 volts comes directly from this positive side. Since this is a wire, they're electrically equal, right? And this side of the wire, you have 0 volts. This is a ground right here. So we could write 0 volts here. So the potential difference, the voltage across the battery, or across the switch rather, is 5 volts. You take the high side minus the low side, and you get this. So I want to talk a little bit more about what's going on inside the wire physically. So we've got a wire here, and it's got 3 electrons in it. There's more in there obviously, but we're just going to talk about 3 for right now. And these electrons are free to move any way they want, but they don't really want to. So this guy doesn't want to move this way because of the interaction right here. He doesn't like this guy. And he doesn't want to go the opposite way for the same reason. He's pretty happy right here. So what would happen if our battery threw in another one of these guys? Well, nobody's going to be happy, right? This electron is going to want to move away from the new electron, but he can't because this guy is forcing himself this way. And this guy can't go anywhere because there's a switch. There's nowhere to go. So the electrons aren't moving per se inside this wire. There may be a little movement from capacitance, and we'll talk about that a little later, but right now let's just ignore capacitance. So nobody's moving. There's just this pressure that's being exerted from this battery. This one electron that's being pushed into this wire is causing all of this pressure and all of this nightmare for all these guys in here. So what we end up with is pressure right here and none here. So that's where we get this potential difference from. So what if we do have current flow? What happens to the pressure if we can do work on some sort of a spindle? This is just like a water wheel right here that I drew to illustrate the point. So I'm going to draw some pipes just like we did earlier. And now our water is flowing. We have some current. And this current is touching this water wheel and it's causing it to spin. So we're doing work on this water wheel. So we have water coming all the way down here. So let's say that this pump right here, this pump, is generating 5 psi over across it. So that's to say that the water here is 5 psi lower than the water here. That's how much power that the pump is putting into the system. All of that power has to be used up somewhere, right? Whether it's going to be used up in some sort of a resistance here or resistance here, but we're going to neglect the internal resistances right now. So there's no other way for the system to lose power other than lose it across the water wheel. So when you only have this one thing in the loop, all of the power is going to go across there. So the potential difference across the engine is the same as the water wheel. So let's do the electrical example and see what happens there. If we draw our wires in this way, and we have a battery that's going to give us 5 volts. Okay, so the potential difference from negative to positive is 5 volts here. We're putting 5 volts of potential into the system. So these wires, we're not losing any voltage here. We're not losing any pressure in these wires, right? So we're going to have 5 volts on this side, and we're going to have 0 volts on this side. So the potential difference across this light bulb is 5 volts. And all of this energy that's being put in from this battery is going into transmitting light. So all the work done here is going into light work here. And that's all I got for voltage, guys. Good luck on your exams. Not too many takeaways for your cheat sheet this one, other than the units for voltage. So good luck, guys.